Hi everyone, welcome to another example of Crunch. Today we are going to look at an e-commerce company and do an analysis on the lifetime value for the average lifetime value for a high risk churn customer. And as you are aware, like we have our data sources on the very left, we have uploaded the file here. By now, you're probably familiar with our UI, but the variables, if you're looking at it for the first time, the variable explorer starts populating as the analysis runs. We call it the magic notebook, and I have already typed in my query. You can, of course, start from scratch, but as soon as I hit next, the system starts working. Now, it goes about doing a sequential thinking, and at the same time it's doing cleaning of data, processing of data, stitching together of information. It actually makes assumptions and tells you where it's making an assumption. It's at the same time sometimes coming back and asking questions as well, where it's very ambiguous, and you see like it's doing it all very fast. So now we're just gonna probably, okay, this is like a lot of queries that we are seeing on the screen. And okay, so it says that the expected lifetime value is about $1,000 per customer, which is cool. But let's get into it, because the minute I tell you that, you'll be like, how did the system actually calculate it? Where do I build my trust? So what it goes and says is that, hey, to calculate the expected lifetime value, if they are retained, various factors and metrics need to be considered, such as average gross margin, correct, the retention rate, the discount rate. Since the term high risk churn customers is not explicitly defined, of course, we didn't tell much in our prompt as well. We may need to assume or define certain criteria for identifying such customers, possibly based on factors like transaction frequency, purchase patterns, customer demographic. That makes sense. So before we calculate the LTV, of course, you need to go in and check for null values. That's always a good practice. So, oh wow, it's running a query which is like basically checking null value in the transaction table. Of course, the query is editable. We have shown examples of what happens. You just need to like change these numbers or change the things in here and go in and hit run, and everything starts rerunning again. Uh, and then that's for some analyst who probably wants to use a custom formula, or who sees that the system is doing something where they would want to exclude a particular segment. It's just in case you want to stay in control. Now it goes and says that there are no nulls, of course, but then it goes and says that let's check for null value in customer demographic. Okay. Oh, it's also saying that there are null in online order, brand, product line, product class, and product size. Okay. The nulls in the order might not be critical for LTV unless this metric significantly affects customer retention or value. Okay. The nulls in the brand and associated products as well as standard cost might be more problematic if these factors are relevant for defining. Okay. Let's see what it does next. So now it's doing the same on customer demographic. Makes sense. You go ahead and see that the customer demographic has null values and date of birth and so on. This should be a problem. So the presence of null is particularly, as this would influence the identification of high risk churn customers, as I was predicting. And that's because when you are doing a customer segmentation, you maybe want to go in and say younger customers, or those who have shopped for a shorter time, they are probably more at risk. So if with that date of birth missing, it could become a problem. But then it still goes and says, okay, we are still going to do a null analysis on customer address. Cool. We'll just move forward. So it doesn't have any null value. Okay, now what's it saying is that we need to define what a high risk churn customer is. This is interesting. So this could be based on a combination of factors such as purchase frequency, of course, the amount spent. That's what I would think like as a human being. And however, since we don't have explicit churn data, we may need to use proxies. Wow. So once we establish the criteria, we can then calculate the lifetime value. For now, let's begin analysis by looking at customer purchasing behavior, which is a very significant step, because right now the system is no clue. It's going and saying, I'm going to look at transactions table and look at the purchase behavior and see if there is anything I can gauge from there. So you see the total spend, the average spend, and so on. Now it goes and says that the total amount spent and the average amount spent per transaction for each customer has been identified. Now we have the purchase behavior. We might correlate it with customer tenure, of course. So you go in and marry this data with the demographic data, which is sitting in another tab in the sheet, because I uploaded the sheet. I know that. So since no explicit criteria were defined, we could consider using basic statistical measure like, of course, quartile or standard deviation. That's fair. Wow, it's amazing how close it is with how I'm thinking in real time. And then it goes and says that there is written the query for it. And the observation here is that based on the average figure, the average number of purchase per customer is 5.72, and the average deviation is this much. Customers who make significantly fewer purchase might be considered as higher risk for churn. But to identify these, we could subtract one standard deviation. Okay, this is, I think, like if you're familiar with standard deviations and formulas, this is a very set in route sort of a set in stone sort of a way of looking at it, which is cool because the system is sticking to it. Now it's going and saying that let's calculate the thresholds and identify customers who fall below them, as they may be higher risk for churn, of course. So it goes and does this query. I'm just very curious on what the query is. Okay, this makes sense. So it's done a whole bunch of things here, and it explains as well. So it goes and says that, hey, we've identified customers who potentially have a higher risk of churn based on their purchase count being less than the average minus one standard deviation, which is like there is an average trend of purchasing, and if someone is like deviating a lot from it, or suddenly showing that deflection, chances are that they are maybe at risk of a churn. So to calculate the expected lifetime value, we typically need to know the gross margin, retention rate, and discount rate, of course. But oh wow, so I knew it that in the database that we have uploaded, we have not provided the gross margin or the retention rate or the discount rate. But I was curious what the system would do here. It goes and says, to progress, let's first analyze the gross margin, which is difference between standard cost of products sold of these high risk customers. The list price and standard cost are in the transaction schedule tools. Will join the customers we have identified as high risk. Okay. So it's going to use a proxy tenure of frequency of purchase. Well, that's very interesting. So it writes the query for frequency of purchase behavior as okay, fair, and then it goes and says that, hey, the average gross margin made by high-risk customers is this much. To continue with LTV, now you see the LTV formula. This is fairly standard again, since we don't have actual retention or discounts rates. Okay, let's make the following assumptions. Assume an average retention rate of 75% per period, which could be a year or another relevant time frame. This is just a placeholder. Wow. It's telling you that it's making an assumption, but it's also telling you this is a placeholder and you should ideally do it from real data. So in here in the query, and by the way, again, like let's say I look at this and I go in and say, no, I don't want it to take 75%. I wanted to take only 50%. So you just go in and change this 0.75 to 0.50 and rerun the query. And then I'm assuming it just goes about identifying the final observation is pretty similar to the result. So very, very, very interesting. We're very excited to see what's essentially happening is the minute you ask a question, there's a sequence of back and forth that you have to do. There is a particular way in which you have to ingest the data in the system. Crunch is taking care of all of that. And in this case, this particular agent that we are looking at has been asked to work better with customer segmentation. So when you go on and say, look at high risk churn customers, it knows much better than what an average agent would do, and which is where we come in and customize these agents for you. That's a quick demo of Crunch for maybe something that e-commerce brands would relate with a little bit. But at the same time, we are doing a sequence of analysis. So if you are a SaaS company, if you are an HR tech company, if you are a finance company, we are having these use cases. And in case you would like to see something specific tried, whether on your data set or on a sample data set, I just type it out or reach out to me anywhere, and I would love to make an example out of that. Thank you. Bye bye.